Hey guys, for this very first lesson, let's take a look and see what monomials are. The entire chapter is going to be dealing with a lot of exponents, so we'll kind of touch on exponents just a little bit today. But the first thing is I want to take a look and teach you what a monomial is and what it's not. A monomial is just simply one term. Okay, that's all that it is. It can be a number, a variable, or you can put a number and a variable together and let them be multiplying each other. And so if you look at all of these examples of monomials right over here, that very first bulletproof, the bullet that we have here, that gives you this one. It can be a number, it can be a letter, it can be a number multiplying a variable. Those would be considered monomials. And these numbers, they can be negative. See this -7? They can be negative. That's fine. Um, the variable can have an exponent on it, but here's the one exception. You're not allowed to have an exponent be negative. So let's make a big deal about that. Let's put some color on, but no negative exponents. And so as we look at the example of non-monomials, if you saw something, let's just make something right here. Let's just call it 3 x to the -2nd power. See this part right here? Because it would have the negative exponent on the x there. Um, we'll see later on with our lessons about why this would get us into trouble and it would violate one of the big fancy rules about monomials right there. Um, here's another rule right here. Monomials do not have addition or subtraction inside of them. And we're not talking about negative numbers. This was not, excuse me, this was not a subtraction sign right there. That is a -7. That's fine. Our problem is that if you see that sign in between two different things, suddenly this is not a negative sign, this is a subtraction sign. If you see the plus sign right here and it's between two different things, hey, that's addition. And so that's what's happening right there. So let's put some color on that. Do not have addition or subtraction in them, okay? So that way you can see like, hey, not a monomial, not a monomial. If it's got a negative exponent, not a monomial. What else do we have over here? No variables on the bottom of fractions. Now, again, in our next lesson or the lesson after that, we will get into how this plays out. But if you see a variable on the bottom of a fraction, if it's anywhere division related, sorry, that x on the bottom right there says it's not a monomial, and you just take it as fact. You don't think about it, you take it. And then it says no radical signs. What are we talking about here? Like the square root signs, or hey, even a cube root sign, right? You should be familiar with those. If not, we'll get you there. But see how this X is underneath that radical sign right there, that square root sign? Sorry, that's not a monomial. So if you wanted to dumb this down, a monomial is basically just one term that doesn't have any negative exponents and no radical signs, and absolutely no letters on the bottom of a fraction. And you can see right up here, these two, they're more than one terms. But that's the basics, and it takes a little bit of looking through there. If you're looking at how to prove if something is a monomial or not a monomial, take a look at these 4 color highlighted areas and use these as little tests that we can give as you look at these monomials, and you'll be able to just like check them right off as you go through and go, oh, this passes, or oh, sorry, it flunks on this one right over here. We've got some work that we'll look at that today right after this lesson, but let's go through here and let's look at the exponent basics down here. This is a monomial, 4x to the 3rd power. That is a monomial, okay? And we're just trying to make sure that you understand what each part is called. A coefficient is simply a number that's multiplying a variable. So do you see that this 4 is multiplying the x? I hope so. So that's why we would call that a coefficient. Now the base is any number or variable, let's call it attached to exponent, okay? So you can see that this base is the x, because that is actually attached to the exponent, which is the 3, you know, the floating number, so to speak there. The exponent, though, is just showing repeated multiplication over and over and over again. So let's rewrite this one in expanded form to show you what this is without an exponent. It would be 4 times not just 1x. That x is happening 3 different times. See, x times x times x. So this expression is the same as this one, but we love exponents so that way we don't have to repeat it over and over and over again. But you can see the repeated multiplication that the exponent was representing. Now, there is one other term that I really want you to get comfortable with, and that is a constant. It's a number that's all by itself. Um, what I'm talking about is right here. This would be considered a constant because the 2 is separated from the x by that addition sign. The 1 is separated from the 4x there. Those are constants. Meanwhile, the 3 right here, we would call this one a coefficient because that 3 is multiplying the variable. We'd say this -7 is a coefficient because it's multiplying the variable. We would also say that the 2 is a coefficient because it's multiplying the variable. I would say that, yeah, 5 would be a constant there, I believe. I can't remember the exact rules about that, but hey, that is just a number there all by itself, so let's just call that a constant also, I suppose. And that should take care of that. Now, as far as this down here, there is a typo right here. Sorry about that. Let's just call this one 4h to the third power, okay? Now, h to the third means that there are 3 h's multiplying. There we go. And that's why I didn't want this to be an h. So that way these multiplication symbols wouldn't look like x's. So there's the 4 with the 3 h's right there. And now the very last thing that we need to go through it's something that I really need you to be on the lookout for is anytime that you have a base that's attached to an exponent, but there's just a negative sign or a minus sign right in front of that, either one, I need you to be on the lookout of just saying, I must slide in a 1 in front of that. I must get that in there, because if you don't, it's going to mess up your understanding. This is equal to -1 times a to the second power. So if you pull out your calculator right now, we can go test this, except for this time we're actually going to give a number to what a is, okay? Let's just say it's a 3. And since this sign is right in front of the 3, I want you to think of it as -1 times 3 to the second power, okay? It's kind of like this. It's kind of like you had parentheses around the 3. And that minus sign is just sitting in front of it, so we put a 1 in there, kind of like that. Now let's go play this out manually without the calculator, and then we're going to use the calculator to check it. Exponents first, so 3 times 3 is 9, so it's -1 times 9. And -1 times 9 is -9. So at this time, could you please go to your calculator and type in -3 and then hit your exponent button, box or whatever, and put into the second power and see, do we get -9? But the problem is that most of the time, until we teach you this lesson, most of the time what happens is that people jump straight in and they go, oh, -3 to the second power, cool. -3 times -3 is, Mr. Tate, that's +9. No, you've got to understand this idea. It's like a -1 times whatever that base is to the second power. I know it's weird, but if you went back and you looked at how we used to have to plug in a value like, let's just say -3x minus y equals 2, and I said, hey, y equals -4x, and I said, please go plug -4x in for the y. I taught you that we would always kind of slide in a 1 right there, so it'd be like -1 times -4x. And then we're like, hey, get rid of parentheses. That's what's happening right over here. That's what's happening right here, in fact. Just slide a 1 in front of that lonely letter right there. Or, in this case, think of it as -1 times 3 to the second power. It's just a really important rule that you're going to see over and over and over again, and we're going to practice that some too.